Beneath the surface of the world's oceans, in a realm of perpetual twilight, and then, in absolute unyielding darkness, there's a global nervous system, a silent, hidden network that pulses with the lifeblood of our modern civilization. It isn't made of organic tissue, but of something far more fragile and in many ways far more powerful. These are the undersea fiber optic cables. Imagine for a moment these hair-thin strands of purest glass, each no thicker than a human hair. They are the core, the very soul of the system. Through them, light itself carries our thoughts, our transactions, our secrets. These delicate fibers are swaddled in layers of protection, a careful wrapping of petroleum jelly to keep out the crushing pressure and the corrosive salt water. Then comes a copper sheath to conduct electricity, not for the data, but to power the signal repeaters that are spaced out along the cable's length, boosting the light signal as it degrades over thousands of kilometers. And all of this is wrapped in layers of plastic, and finally, in thick, galvanized steel wires, giving it the appearance of a simple, robust garden hose, belying the incredible complexity within. They just lie there on the abyssal plains, draped over underwater mountain ranges, and sunk into the silt of deep-sea canyons, crisscrossing entire continents in a vast, intricate web. And through these fragile technological arteries flows 99% of the world's internet traffic. Not some of it, not most of it, nearly all of it. Your messages to loved ones, whispered across oceans in an instant. Your emails, the mundane and the monumental, all encoded into pulses of light. The financial transactions, trillions of dollars a day, that keep the global economy breathing. The secure military communications that global security, the very balance of power, depends upon. Even this very story you're listening to right now, the sound of my voice, the thoughts behind these words, it most likely left a server on land, plunged into the cold, dark water, and traveled along the silent, lonely bottom of the ocean to reach you wherever you are. It's a strange and beautiful thought, isn't it? That our most ephemeral, most digital connections have such a profound physical reality, resting in the deepest, most inaccessible places on Earth. These aren't just cables. They are so much more than that. They're the lifelines of the modern world, the invisible architecture that supports our interconnected existence. They are the reason you can see the face of a family member halfway around the world. The reason a student in a small town can access the libraries of a great university. The reason our world, for all its divisions, is more connected than ever before in human history. And for all their importance, for all the layers of steel and plastic that protect them, they're vulnerable. Astonishingly so. A single ship, large and lumbering, carelessly dropping its anchor in a busy shipping lane, can sever an entire region's connection to the world. It happens more often than you might think. A sudden internet outage across a country can sometimes be traced back to a single, thoughtless moment at sea. And while accidents are one thing, deliberate action is another entirely. In recent years, Russian research vessels and submarines have been spotted, moving with unusual interest near key cable routes in the North Atlantic and the North Sea. They linger, moving slowly, methodically, in patterns that don't align with typical scientific surveys. This activity, tracked by satellite and naval intelligence, has sparked a deep and growing wave of concern within Western governments about the potential for sabotage. The ability to cut these connections isn't just a technical problem, it's a strategic threat of the highest order. But that's just the tip of the iceberg. That's what happens near the surface, in relatively shallow, accessible waters. The real game, the future of this silent conflict, is moving deeper. Imagine a device. Not a ship's anchor, not a crude tool. Imagine a sophisticated, autonomous robot designed to operate in the crushing pressures and total darkness of the deep ocean. A device capable of quietly, stealthily navigating the abyssal plains, finding these slender cables, and with a precise, metallic claw, cutting these arteries, thousands of meters deep. Far from prying eyes, far from any satellite or patrol boat, without a single witness to the act, the connection would simply go dark. An entire nation's data flow could be choked off, and the world would be left scrambling, wondering if it was a deep-sea earthquake, an underwater landslide, or something far more deliberate. In early 2025, China showed the world exactly that, a deep-sea robot, a literal cable cutter. It was unveiled with little fanfare, presented to the international community as a tool of progress. Officially, its purpose is to find and repair damaged infrastructure on the sea floor, a noble and necessary task. But any tool, as we know, has two sides, right? A scalpel can be used to heal or to harm. A hammer can be used to build or to break. The same is true for a deep-sea robot. A device built with the precision to find a cable a few inches thick in the vast darkness of the abyss, and to carefully repair its delicate internal fibers, can just as easily be used to sever it. The same manipulators, the same guidance systems, the same power source. The only thing that changes is the intent. The command sent from the surface. Now, to be clear, there is absolutely no public proof that this specific device has ever been used for anything hostile. But the mere possibility that it could be, that single, quiet fact, that alone changes the rules of the game. It fundamentally alters the strategic landscape. It turns the seafloor, for so long a realm of scientific mystery and natural wonder, into a potential 21st century battlefield. A silent, cold, and dark theater of operations where the future of global power could be decided. You know, when you think about it, when you really let the idea settle in your mind, the struggle for control over the world is already shifting beneath the waves, quietly, inexorably. And while so many of us, our leaders, our media, are looking up at space, at the race to Mars, at the constellations of new satellites, one country, China, is diving deeper, moving faster, and investing more aggressively than any other nation in history. They're not just building one or two advanced submersibles, they're deploying entire fleets of deep-sea robots. They're in the advanced planning stages for building semi-permanent underwater bases, like a clandestine international space station on the ocean floor. And they are quietly, methodically preparing to map, to understand, and ultimately to claim what lies on the bottom of the sea before anyone else can even get there consistently. And they're not just doing it for the pure, noble pursuit of science. That's part of the story, the public face of the endeavor. But it is not the whole story. While the United States, for a complex mix of political and budgetary reasons, cuts back its ocean research programs, China is racing into the abyss with a sense of national urgency that is breathtaking to behold. The funding is immense, the political will is absolute, and the progress is startling. So what's really down there? What is so valuable in those crushing, cold depths that it's driving one of the world's great powers into this silent, high-stakes race? What secrets, what resources, what strategic advantages are hidden in the last, true frontier on our own planet? We spent weeks, months even, digging through Chinese scientific research papers, government news reports, tracking the movements of their research vessels, and speaking with oceanographers, naval analysts, and robotics experts. And what we found points to a much bigger story than just a few robots and some vulnerable cables. A story that is unfolding in the darkness, far from the public eye. A story that almost no one is talking about. Okay, so to grasp the full scale of what's happening, we need to pull back for a second. We need to ground ourselves in the geography of this hidden world and just understand where we are. This is the Mariana Trench. a gigantic crescent-shaped underwater canyon in the western Pacific Ocean, just to the east of the Philippines. When you look at it on a map, it seems like just another blue patch of ocean. But it is a scar on the face of the planet. It's the deepest place on Earth. It is, without exaggeration, one of the most extreme and hard-to-reach places there is. To get to the bottom, you have to travel not just horizontally across the sea, but vertically, down through the ocean's entire water column. It's a journey through different worlds, each with its own rules, its own light, its own pressure, and its own strange inhabitants. Let's make that dive. Let's descend together, slowly, layer by layer. We start at the surface, in the world we all know. This is the photic zone, a name that comes from the Greek word for light. It's also called the epipelagic zone. It's warm here, bathed in the familiar light of the sun. The water is a brilliant blue. This is the world you know. Vibrant coral reefs teeming with life, massive schools of shimmering fish, sea turtles gliding gracefully through the water. This is the part of the ocean we swim in, surf in, snorkel in. It's the ocean of postcards and nature documentaries. It feels safe, familiar. But this familiar, sunlit layer only goes down about 200 meters, or roughly 650 feet. In the grand scheme of the ocean's depth, that's basically nothing. It's the thinnest of skins on a vast and mysterious body. Below that, everything changes. The rules of life, the very nature of the environment, begin to transform. And so we enter the twilight zone, the mesopelagic, from 200 to 1,000 meters below the surface. Sunlight, which was so abundant just moments ago, begins to fade dramatically. It's a slow, beautiful, and slightly unnerving descent into darkness. The brilliant blues give way to a deep, dusky indigo. The warmth of the surface is gone, replaced by a persistent, encroaching cold. As you descend, the pressure builds relentlessly. At 1,000 meters, it's about 10 times what we feel at sea level. That's enough pressure to crush most surface-dwelling creatures. A human lung would collapse. The wooden hull of an old sailing ship would be splintered into fragments. The animals here must be built differently. This zone is home to some of the most bizarre and beautiful life on the planet. You've got the oarfish, a silvery serpent-like giant that can grow longer than a city bus, its long, ribbon-like body undulating through the gloom. Sailors of old who saw this creature surface probably thought they had seen a true sea monster. And this is a sea angel, a tiny, transparent winged slug that flutters through the dark with an ethereal grace. It is a predator, a hunter of other deep-sea snails, but it moves with the delicacy of a dream. As sunlight disappears and the pressure rises, animals here adapt in the strangest ways. Many of them lose their color, becoming transparent or a uniform, non-reflective black or red, colors that are effectively invisible in the dim blue light. They grow oversized, incredibly sensitive eyes to catch the very last photons of light filtering down from the world above. Or they evolve these soft, gelatinous, flexible bodies that contain very little air and won't collapse under the immense and growing pressure. The deeper you go, the more alien the world becomes. It feels less and less like our planet and more like another one entirely. Well, it's at this point, 1,000 meters down, that you cross another invisible threshold. You enter the midnight zone, the bathyal zone, absolute, permanent darkness. From this point on, the sun is just a memory. It has no influence here. The only light you will see is the light that the creatures make themselves. It's a cold, living light, a natural glow known as bioluminescence. It's the language of the deep, a flash to startle a predator, a lure to attract prey, a gentle glow to find a mate in the endless black. The animals here look like something out of a science fiction horror film, yet they are very real. They are masterpieces of evolution, perfectly suited to a world of no light, immense pressure, and scarce food. You see creatures with glowing lures dangling in front of gigantic mouths filled with needle-sharp teeth. You see fish with transparent bodies, their internal organs visible. And you see this terrifying yet strangely graceful creature. This is the Magnappina squid, or big fin squid. It has these long, spidery arms that can reach over 6 meters, more than 20 feet, and they just dangle there in the dark, held at a strange, rigid, 90-degree angle from its body, like puppet strings. Scientists still aren't sure exactly how it uses them to hunt. It is pure, unadulterated nightmare fuel, and yet it is a functioning, successful part of this deep, dark ecosystem. Down here, the pressure continues to build to 100 times what we feel at sea level. That's about 1,500 pounds of force on every single square inch of your body. To make that more concrete, imagine a full-grown dairy cow standing on a postage stamp. Now imagine that postage stamp is on your fingertip, and that same force is surrounding you, pressing in from every single direction, simultaneously and relentlessly. I mean, one of the most famous creatures from this zone is the blobfish. It has become something of an internet meme, voted the world's ugliest animal. But in its natural habitat, near the upper end of the midnight zone, around 1,200 meters deep, it looks like a normal, if slightly grumpy, deep-sea fish. It is perfectly adapted to the intense pressure. Its body is a gelatinous mass with a density just slightly less than the water around it, allowing it to float effortlessly above the seafloor without expending energy on swimming. But when it's brought rapidly to the surface by a fishing trawler, all of that external pressure disappears. The internal pressure of its body is no longer balanced, and the blobfish expands into that shapeless, gelatinous, sad-looking blob you might have seen online. Its appearance on the surface is a mark of extreme trauma. The blobfish is a perfect, if poignant, reminder of just how extreme the pressure is down here, and how life, in its incredible ingenuity, can adapt to survive it. But we are not stopping. We keep sinking, down, down through the cold, pressurized darkness. At 4,000 meters, or about 13,000 feet, you reach what's called the abyssopelagic zone, or simply the abyss. The name itself speaks of a bottomless, unknowable void. It's cold, just a few degrees above freezing. It's dark, a darkness so profound it feels like a physical substance. And it is quiet, the kind of silence that is rare on the surface of our noisy world. Life seems scarce here, a stark contrast to the teeming reefs of the surface. But it isn't absent. And this is where the seemingly barren seafloor might surprise you. At first glance, looking out from the porthole of a submersible, it just looks like plain, boring, endless mud. A flat, featureless desert. But that mud is deceiving. That mud is a story. Have you ever wondered what happens to everything in the ocean when it dies? The countless fish, the great sharks, the massive whales, even the tiniest microscopic plankton that form the base of the entire marine food web. Eventually, everything that lives and dies in the vast water column above sinks. And so, some of it falls as waste, the droppings of other creatures. Some falls as tiny particles, the exoskeletons of plankton, the scales of fish, digested and expelled by other creatures on the long journey down. Over time, over millions and millions of years, it all builds up. For eons, all this organic matter drifts down and settles gently onto the seafloor. It's like a gentle, endless, silent snowfall, a phenomenon scientists poetically call marine snow. Layer by layer, particle by particle, it forms a soft, carbon-rich mud. In some places, that mud is over a kilometer thick, more than 3,000 feet deep, made from the accumulated remains of everything that once lived in the sunlit waters far, far above. And while these layers preserve a perfect, undisturbed history of the ocean's past, like the rings of a tree, they also trap enormous amounts of carbon, pulling it out of the atmosphere and locking it away in the deep. This process turns the deep sea into one of the planet's most powerful and important natural carbon sinks, a critical regulator of our global climate. Well, even with all that marine snow constantly piling up, providing a slow drizzle of nutrients, life down here is still scarce. Energy is at a premium. Most creatures are small and slow-moving, adapted to conserve every calorie. They survive on the scraps that fall from above, adapted to a world where a real substantial meal is an incredibly rare event. But every so often, something incredible happens. Something massive sinks. A lottery win for the inhabitants of the abyss. And when it does, it changes everything. This here is what scientists call a whale fall. When a dead whale, weighing many tons, sinks to the seafloor, it becomes a sudden, massive magnet for life. And you can see it happening right here, captured by a remotely operated vehicle. Deep-sea scavengers, like the ghoulish-looking hagfish and sleeper sharks, move in within hours, drawn by the scent from miles away. They are the first wave. They tear at the flesh, and the feast begins. After them come the smaller opportunists, crabs, worms, snails, and bacteria. Over time, an entire complex ecosystem forms around the remains, an oasis of life surviving on a single fallen body. You see these tiny, reddish, hair-like things stuck to the bones? Those are ossidax worms, sometimes called zombie worms. They have no mouths or stomachs. Instead, they secrete acid to dissolve the bone and have symbiotic bacteria in their roots that digest the fats and oils locked inside. A single large whale can support a thriving, diverse community of life down here for decades. It's a sudden, massive burst of energy in a place where opportunities are rare. And when that opportunity comes, life, in its relentless opportunism, doesn't waste a single moment. And yet, even with such a bounty, surviving here still isn't easy. The temperature is just a hair's breadth above freezing, and the pressure is absolutely crushing, more than 400 times what we feel at the surface. That's like trying to balance 7 full-grown elephants on your fingertip, and feeling that immense weight pressing in from all sides, trying to find any weakness, any air pocket to obliterate. You're descending further still. The abyss was not the bottom. You're now deeper than 6,000 meters below the surface. This is the Hadal Zone, named after Hades, the Greek god and ruler of the Underworld. It is a fitting name. This is trench territory. You see, from this point on, the only places on Earth that go deeper are the great oceanic trenches. These are not just canyons. They are places where one of the Earth's tectonic plates is sliding beneath another, a process called subduction, pulling the seafloor down into these impossibly deep gashes. Very few submarines, only a handful ever built, can even reach this far down. The pressure in these depths is more than 600 times what we feel at the surface, and it only increases with every meter. To survive it, a submersible needs a near-perfect, pressure-proof design. Typically, a titanium alloy sphere, machined with incredible precision. Something only a handful of submersibles on Earth have ever achieved. Any flaw, any microscopic crack in a weld or a viewport would result in an instantaneous and catastrophic implosion. And finally, at nearly 11,000 meters, almost 7 miles down, we hit the bottom of the Mariana Trench, That's a depth greater than Mount Everest is tall. If you could place Everest on the sea floor here, its peak would still be more than a mile beneath the waves. And the pressure is so intense, so mind-bogglingly extreme, that it would feel like 90 full-grown elephants pressing into every fingertip-sized area of your body, from all sides. The water here is measurably denser than at the surface due to this compression. But here's the most incredible part, the part that still astonishes scientists. Life still exists. Let's see, some of it's in strange and ancient forms, like these giant single-celled organisms called xenophyophores. They look like pale, delicate, lacy sponges, but each one is a single massive cell. They construct their intricate skeletons from the sediment around them and filter tiny bits of food from the seafloor mud. They are specialists of the extreme, thriving under pressure that would instantly crush almost any other form of life. Tiny, pale, shrimp-like creatures called amphipods, some of them surprisingly large, creep silently across the mud, scavenging for any morsel of marine snow that has completed its long journey. Ethereal-looking hadal snailfish, pale and gelatinous, glides slowly through the water, the deepest living fish ever discovered. Life here is rare, to be sure, but it's not absent. It's perfectly, beautifully adapted to the most extreme environment on our planet. So what else could be in these trenches? We know life survives. We have seen these small glimpses. But there's still so much more we haven't seen. The trenches represent the largest, unexplored habitat on Earth. Let's stay at the bottom of the Mariana Trench for a moment. Let's try to comprehend the scale of this place. This vast underwater canyon stretches for more than 2,500 kilometers, or 1,550 miles, across the Pacific. That's about the same distance as from New York City to Denver. But not every part of it is the same depth. It's not a uniform ditch. It's a complex landscape of its own. Because near its southern end, there's a particular point, a small, steep-sided valley that plunges even deeper than the surrounding trench floor. A pit within the Great Trench. If the Mariana Trench is the deepest part of the ocean, then what is the deepest part of the trench? And so, that's where we find Challenger Deep. This is it. The most extreme depth on Earth's seafloor. The absolute bottom. It doesn't go any deeper than this. For most of human history, it was a place of pure speculation. It was first successfully reached in 1960. A Swiss engineer and oceanographer, Jacques Picard, and U.S. Navy Lieutenant Don Walsh made the historic descent in a most peculiar-looking submersible, the Bathyscaphe Trieste. It was essentially a reinforced steel sphere for the two men, attached to a massive float filled with gasoline, which is lighter than water and less compressible. That first pioneering dive lasted just 20 minutes on the bottom. They saw a flatfish and some shrimp, proving life could exist there, and then they ascended. Then, for over 50 years, an entire half-century, no one followed. The technical challenges were too great. The cost too high, the motivation lacking. The bottom of the sea was left to its silence, until the filmmaker and famed explorer James Cameron, a man with a lifelong passion for the ocean, decided to go. He dove solo in 2012 in a submersible he helped design, the Deep Sea Challenger. He captured stunning high-definition footage, gathered scientific samples, and made it back safely. It was a triumph of private exploration. A few years after that, a driven explorer and multimillionaire from Texas named Victor Vescovo built a new, even more high-tech submarine called the Limiting Factor. He made multiple dives to the bottom of Challenger Deep, meticulously mapping the seafloor and collecting detailed data. But each of these incredible missions, from the Trieste to Cameron to Vescovo, had something in common. They were rare, extremely expensive, bespoke expeditions, and mostly one-offs. They were the oceanic equivalent of the first Apollo missions. Historic, heroic, but not sustainable or scalable. That is, until China got involved. And they brought a different philosophy to the problem. And now we come to the year 2020. In the midst of a global pandemic, China sent a team of 3 taikonauts of the deep to the bottom of Challenger Deep in a submersible named Fenduje, which means striver. It was their deepest dive ever, a moment of immense national pride, broadcast across the country. But here's what made their effort fundamentally different from what had come before. They didn't stop. They didn't pack up the sub and put it in a museum. They doubled down. Fenduje was designed not for one historic dive, but for many. It was built to be a workhorse. Each new submersible they developed was smaller, more advanced, and designed to return to the abyss again and again and again. They were turning a daring feat into a routine procedure. By 2024, China had moved beyond these kinds of crude missions. And this is what the new frontier looked like. A small, autonomous robot, no bigger than a shoebox, dropped over the side of a ship into one of the most hostile environments on Earth. No pilot, no protective titanium sphere, no life support, and most importantly, no cable tethering it to the surface. It crawled across the muddy seafloor under its own power, guided by its own intelligence, mapping, sampling, observing. And then, it came back to the surface intact. You know, I was just thinking, that single, unheralded moment, the return of that little robot, marked a huge, almost invisible shift in the history of ocean exploration. It was a shift from rare, expensive, one-off missions to something repeatable, scalable, and far more ambitious. Because if one tiny, relatively inexpensive robot can do what used to take a massive, multi-million-dollar crude submersible, what happens when you build 10 of them? Or 100? What happens when you build a fleet of them? Fenduje wasn't the end of their ambition. It was the start of something much, much bigger. China is now developing a whole new generation of deep-sea robots. They are not all the same. They are small, specialized, autonomous machines that glide on underwater currents like albatrosses of the deep, crawl along the seafloor on metallic legs like crabs, or even flex their way through the water using bio-inspired artificial muscles. Built for different tasks, these robots are designed to work together in coordinated fleets or swarms. They can cover more ground more quickly and more often, and they can do it at a fraction of the cost of a single crewed submarine. It's the difference between sending a single astronaut to explore a planet and sending 1,000 robotic rovers. Okay, so what are they hoping to find with this new robotic army? What is the prize that justifies this colossal investment? The deep sea holds more than just strange creatures and extreme pressures. It holds the secrets to life's origins and potentially the keys to our future. This here, where you're looking at, is a cold seep. It's a place on the ocean floor where methane and hydrogen sulfide, gases from deep within the Earth's crust, seep up from beneath the seafloor. It may not look like much, just some shimmering water and some clusters of shells. But these gases, which are toxic to most life we know, are a source of energy that feeds entire, unique ecosystems. Mussels, clams, and forests of giant tube worms thrive here, surviving in total darkness, not through photosynthesis, but through a process called chemosynthesis. They have symbiotic bacteria in their bodies that convert the chemical energy of the seeping gases into food. They are living off the energy of the Earth itself, not the sun. Why does this matter so much to China? Because these cold seeps are more than just strange deep-sea oases. They are natural test beds for understanding the limits of life. They show us how life can thrive in the most extreme conditions, without light, under immense pressure. They offer potential models for new, future energy systems. And, perhaps most tantalizingly, they resemble the environments that scientists believe may exist on some of the moons of Jupiter and Saturn, like Europa and Enceladus, which are thought to have liquid water oceans beneath their icy shells. To a country with ambitions to control the deep ocean and to reach beyond Earth into the solar system, places like this are scientifically priceless. And so now we look at this. What looks like frozen, slushy snow packed into the seabed is actually something far more unusual and far more valuable. This is methane hydrate, or, as it's more evocatively known, fire ice. It forms under the specific conditions of high pressure and cold temperatures found in the deep ocean, when methane gas gets trapped inside a crystalline cage of frozen water molecules. It looks like ice, but it's not. And yes, if you bring a piece to the surface, where the pressure is released, and you light it with a match, it burns with a steady, bright flame. Scientists around the world are studying it as a potentially enormous future fuel source. The amount of energy locked away in methane hydrate deposits globally is thought to be greater than all other known fossil fuels combined. But extracting it safely is incredibly risky and technologically challenging. If you disturb the seafloor too much, you could trigger massive underwater landslides or, even worse, release large amounts of methane, a greenhouse gas many times more potent than carbon dioxide, directly into the ocean and the atmosphere, with catastrophic consequences for the climate. The fact that we're even seeing this, here at these depths, captured in high resolution by an autonomous robot, shows just how far deep-sea exploration has come. And it raises the next obvious question. What other resources, what other treasures might be buried down here? You see these round, lumpy, dark rocks scattered across the vast plains of the abyss? They look like potatoes or discarded charcoal briquettes just resting on the surface of the ocean floor. You're looking at polymetallic nodules. For decades, they were a scientific curiosity, small, potato-sized rocks that grow with excruciating slowness over millions of years, as minerals precipitate out of the seawater and build up in concentric layers around a tiny nucleus, like a pearl forming around a grain of sand. Inside these unassuming rocks, they contain a wealth of valuable metals, including cobalt, nickel, copper, and manganese, as well as smaller amounts of rare earth elements. These are not just any metals. These are the essential ingredients for building the technologies of the 21st century. The high-capacity batteries in our smartphones and electric vehicles, the powerful magnets in wind turbines, the circuitry of our most advanced renewable energy systems. As the world tries to transition away from fossil fuels, the demand for these specific metals is skyrocketing. And this is how they plan to collect them. A massive surface ship, a specialized processing plant at sea, lowers a robotic mining vehicle, the size of a combine harvester, down to the seafloor on a long tether. That collector vehicle then crawls methodically along the bottom, like a giant vacuum cleaner, scooping up the top few inches of sediment, along with the nodules. Everything it collects, rocks, mud, and any unfortunate creatures in its path, is pumped back up through a giant pipe, a riser, to the ship several miles above. Right, so that brings us to the immense and largely unknown environmental cost. As these colossal collector vehicles crawl across the seabed, which has been undisturbed for millions of years, they kick up massive, dense clouds of sediment. These are known as plumes. These dark, choking clouds can smother the fragile, slow-growing habitats of deep-sea creatures like corals and sponges. They can drift on deep ocean currents for hundreds of miles, affecting vast areas of the ocean far beyond the actual mine site. After the nodules are separated from the sediment on the ship, a second plume of wastewater and fine particles is often pumped back into the ocean, usually at a mid-water depth, adding to the chaos and potentially harming the ecosystems of the twilight zone as well. If this new industry ramps up to a commercial scale before we have truly independent, long-term studies to understand the full impact, the damage to the deep-sea environment could be profound and irreversible. Some scientists warn that the seafloor ecosystem could take centuries or even millennia to recover, if it ever recovers at all. And with no clear international consensus on how to manage the waste, where to put it, or who is liable for the damage, one thing is clear: we are charging headlong into the deep without a full picture of the cost. I mean, many marine biologists are deeply, profoundly concerned about the prospect of deep-sea mining as a whole. Those ecosystems are characterized by extreme longevity and incredibly slow rates of growth and recovery. They are exquisitely fragile. Disrupting them on an industrial scale could wipe out entire species we haven't even discovered yet, and destroy unique habitats that took millions of years to form, all for a short-term gain in resources. All of this, the nodules, the fire ice, the cold seeps, and the advanced tools to reach them, makes one thing crystal clear: the extreme deep sea is no longer out of reach. It's rich in resources that are critical for our future, and it's becoming more and more accessible by the day. But if the deep sea becomes the next great resource frontier, who gets to decide how it's used or how it's protected? Right now, the international regulations governing the high seas are sparse, patchwork, and difficult to enforce, and national ambition is rapidly outpacing global oversight. Well, China sees that opening. They see that vacuum of governance. They're not just observing or experimenting anymore. They're getting ready to extract, to claim, to secure what's down here before anyone else does. They are playing a long game. They're investing in a long-term, persistent presence in the deep. Right now, as we speak, they're in the advanced design and planning stages to build a permanent base on the seafloor, possibly in the South China Sea, at a depth of 2,000 meters. It's designed for 6 scientists to live and work for up to 30 days at a time. It's a concept straight out of science fiction. It's like an international space station, but on the ocean floor, a habitat in the abyss. And it gives China something even more valuable than minerals or energy. It gives them time on the bottom, time to test new tools and technologies in the real environment. Time to monitor the deep ocean environment continuously, not just on brief expeditions. Time to gain the kind of operational experience, the institutional knowledge of how to live and work in the deep that few other nations are even attempting to acquire. Down here, in this extreme environment, access is just the beginning, the first step. What really matters is what you do with that access. The ability to stay, to work, to endure. China is building the tools, the knowledge, and the human experience needed to operate in the deep ocean, not just once, for a fleeting moment of glory, but continuously as a matter of routine. That's how they're pulling ahead. By turning exploration into repetition, and by turning repetition into dominance. The deeper you go, the more hostile the environment becomes, the less room there is for error, for guesswork. And the countries that are investing now, in the hardware, in the research, in the people, are the ones who are setting themselves up to control what lies beneath for the century to come. And so control, strategic and economic, is already shifting, silently, underwater. The only question now is who's getting there fast enough to shape what happens next. Every one of these advanced deep-sea robots starts not in a factory, but as a human idea. Someone, a young engineer, a creative scientist, imagining, designing, and then building something capable of surviving in a place where people cannot. And right now, the country that is supporting those people, funding those ideas, and encouraging that ambition the most is China. They're pouring truly massive resources into ocean science and engineering, building new state-of-the-art research labs, funding ambitious, full-scale programs, and training the next generation of ocean engineers, marine biologists, and deep-sea roboticists. And they're not just investing in their own domestic talent. They're actively attracting top minds from around the world with high salaries, well-funded labs, and the promise of working on the most exciting, cutting-edge projects in the field. Meanwhile, in a strange and worrying parallel, countries like the United States are, in many areas, pulling back. Budgets for fundamental scientific research are often the first to be targeted in times of fiscal austerity. The current administration has proposed significant funding cuts for NOAA, the National Oceanic and Atmospheric Administration. This is the very agency responsible for exploring, protecting, and understanding U.S. ocean territory, which is one of the largest in the world. While China is flooding its oceanographic institutes with money, talent, and a powerful sense of national momentum, the U.S. is at risk of sidelining the very agency built to compete, to explore, and to lead in this critical domain. Top scientists are walking away, not because they've lost their passion or their interest, but because the long-term funding, the stability they need to conduct multi-year research projects, is gone. When funding for science dries up, research grinds to a halt, progress stagnates. But when a country puts real, sustained support behind its scientists and engineers, discoveries happen. Breakthroughs are made, and those discoveries, that knowledge, that capability, they shape the future. So, what did China actually discover down there? It's not just a new species of fish or a strange geological formation. They discovered something far more important. They discovered a way in, and they found a compelling reason to stay. They're transforming deep-sea exploration from a series of rare, heroic missions into a scalable, industrial-scale strategy, using fleets of compact, autonomous robots and planning for permanent underwater research stations. They are systematically building the infrastructure needed to operate in a realm where few others can. They've mapped and identified resources that could help power the next century of their economic growth. But more importantly, they're developing the tools, the technology, and the experience to control access to those resources. They're not just exploring for the sake of knowledge, they are positioning themselves to dictate what happens next in the deep ocean. And while the U.S. debates research budgets and pulls back from its historical leadership role in ocean science, China is surging ahead, moving faster, diving deeper, and operating with a clear, long-term strategic plan. Beneath the waves, out of sight and out of mind for most of us, a new frontier is taking shape, one that could define the economic and geopolitical landscape of the century ahead, and what we as a global community choose to explore, and how we choose to do it, will shape more than just the future of our oceans. It will shape the future of power, security, and global influence for generations to come. The deep sea is one of Earth's last, truly wild, vast, and largely untouched places. Once its fragile, slow-growing ecosystems are disturbed by industrial activity, there may be no going back. Rushing in without proper oversight, without a deep understanding of the consequences, could wipe out entire ecosystems before we even know they exist, and trigger a cascade of consequences that we don't yet understand. I them stand. You know, we've been at a similar crossroads before. In the mid-20th century, when the Great Race was to the moon, the initial fierce competition between two superpowers eventually gave way to a spirit of collaboration. The International Space Station, a marvel of engineering and diplomacy, orbiting silently above us, proved that nations with different ideologies and competing interests can work together to push the boundaries of human knowledge and to protect what matters for all of humanity. We need that same mindset again, now, for the deep ocean. A mindset of collaboration, of shared stewardship, of precaution, not just to explore the deep, but to understand it and to protect it. Because if only one nation, driven by its own strategic and economic interests, achieves overwhelming dominance and controls access to the last unexplored part of our own planet, the cost won't just be scientific or environmental. It could be something we all feel, in ways we can't yet predict. a shift in the fundamental balance of our world, originating from the cold, silent darkness miles beneath the surface of the sea. Before we could ever dream of sending robots into the abyss, we first had to learn how to even look at it, how to conceive of it in our minds. For millennia, the ocean deep was a blank slate for the human imagination, a vast, dark canvas where we projected our most primal fears. The very word abyss, from its ancient Greek roots, abyssos, means without a bottom, an endless, terrifying void. What kind of ungodly monster, what sort of malevolent entity would find a place like that hospitable? It was the natural home for all things demonic and destructive. Religion and mythology offered chilling descriptions, often comparing the great sea creatures to Satan himself. So when someone finally created a map of the sea that actually had detailed portraits of these monstrous inhabitants, it was bound to get some serious attention. This map, a masterpiece of cartography and imagination, was called the Carta Marina. It was first printed in the year 1539. Every inch of its massive 2-square-meter surface was covered with intricate, hand-carved drawings, landmarks, and extensive notes in Latin. It was, for its time, packed with the latest, most cutting-edge information of the era on the geography of Northern Europe, on marine life, and on navigation. But the main reason this map has gone down in history is that it's a 480-year-old, beautifully rendered snapshot of our deepest, most profound fears about the ocean. It was a map not just of the seas, but of the human psyche. In an age before the rigors of science, before the first tentative explorations of the deep, people genuinely believed that the depths were teeming with horrific monsters, and the Carta Marina made their existence official, giving them a form and a name. It depicted their malevolence in striking, unforgettable detail. From the icy waters off Greenland all the way to the coast of Norway, a menagerie of sinister creatures were shown creating chaos on a grand scale, devouring sailors whole, capsizing ships, and dragging their helpless victims down into a hellish, watery abyss. And so the creator of this map, a Swedish Catholic priest, writer, and historian named Olaus Magnus, he wasn't a charlatan or a fantasist, he was a scholar. He gathered his information firsthand, meticulously compiling stories from fishermen, from sailors, from village gossip, all of it seasoned with a healthy dash of medieval superstition. In his time, the ocean inspired a special, potent kind of terror. Ships would sail over the horizon and simply never return, swallowed, it was assumed, by a great maw teeming with biblical demons like the Leviathan and the legendary Kraken. No one, except for the unlucky few who'd made a one-way trip to the bottom, had ever actually seen the abyss. Of course, people had tried to look deeper long before this. The great Greek philosopher Aristotle, back in the 4th century BC, is widely considered to be the world's first true marine biologist. He spent countless hours dissecting sea creatures, studying their behavior with a careful, analytical eye. He even correctly figured out that whales and dolphins were not fish, but air-breathing mammals. But after the fall of Rome, his rigorous scientific approach was largely forgotten. The Roman historian Pliny the Elder, writing in the year 77 AD, preferred to spread sensational tall tales about sea monsters, stories of 300-foot eels and fish so large they were mistaken for islands. Throughout the long centuries of the Middle Ages, it was Pliny's fantastic stories, not Aristotle's careful, sober observations, that were widely considered to be the truth about the sea. Okay, so with the arrival of his Carta Marina, Olaus Magnus set out to illuminate this darkness. His timing was perfect. It was the great age of discovery, and the people of Europe were hungry for anything new, unusual, and especially ferocious. The known world was expanding rapidly, and it seemed to be full of both wonders and terrors. Magnus, as both a cleric and a scholar, filtered everything he learned through the lens of the Bible, and through the classical works of Aristotle, Pliny, and Ptolemy. His map became an instant icon, a mirror that reflected our collective dread of the deep back at us in the most delightfully frightful way. A lot of the monsters Magnus drew bear a passing resemblance to whales, though they look, well, far more demonic. It's clear he was familiar with the general shape and size of the animals, but he seems to have been confused about which were simply whales and which were some other, more sinister kind of monster. For example, the male narwhal, that shy, elusive Arctic whale with the single protruding spiral tusk, Magnus saw it not as a whale, but as the monoceros or unicorn fish, a ferocious sea monster capable of piercing and sinking ships with its horn. He must have spoken with coastal villagers who had found the carcasses of beached whales, bloated by decomposition, battered by rocks, and bitten up by sharks, looking, to be fair, pretty sinister. What was a medieval farmer supposed to think when he stumbled upon the immense body of a 50-foot sperm whale, with its massive square head and its jaw full of 7-inch conical teeth? Without any scientific context or knowledge of marine biology, it would have been an experience of pure, unadulterated terror. You know, fear can take strange and wonderful forms. It's no surprise that our primal fear of the abyss, which the psychologist Carl Jung famously compared to the madhouse of the subconscious, has produced some of the strangest and most enduring images of all. We populated that dark, unknown space with phantoms dredged up from the deepest corners of our own minds. The genius of Olaus Magnus was that he gave them a home and put them all down on paper. But as seafaring became more common and more profitable, the great European monarchies realized the ocean was more than just a den of supernatural trouble. It was a boundless place to make money. By the mid-17th century, the terrifying drawings of horrific, whale-like predators menacing ships were gradually replaced on maps by more practical images. Images of ships actively engaged in the business of whaling. Sperm whales on these new maps no longer had tusks and blazing demonic eyes. They had harpoons sticking out of their backs. The monsters were, in a sense, gone. Vanquished not by heroes, but by commerce, reduced to commodities like candle wax and lamp oil. The 17th and 18th centuries brought seismic shifts in our understanding of the natural world. This was the Enlightenment, and a man named Carl Linnaeus arrived on the scene. In 1728, he came to Uppsala University in Sweden and soon made history by creating the binomial taxonomic system we still use today to classify all living things. Thanks to Linnaeus, we now know the orca by its scientific name, Orcinus orca, not by Magnus's preferred name, the Grampus, or by Pliny's chilling description, an enormous mass of flesh armed with savage teeth. This was a huge, revolutionary leap forward. It began the long process of pushing aside rumor, superstition, and wild fabrications about monsters, replacing them with cool, detached, rational assessment. The age of Olaus Magnus and his monsters gave way to an age of measuring, classifying, debating, and reasoning. And so the next wave of ocean investigators, they weren't going to be content with stories. They weren't going to wait for these shadowy, deep-sea life forms to just reveal themselves. They wanted to comb the depths with nets and dredges and find them. The 19th century was hungry for empirical evidence. They wanted to collect specimens, to study them under a microscope, to dissect them, to understand their life cycles. And they wanted to conduct physical experiments to answer some basic but still baffling questions about the ocean. How deep was it, really? What was the seafloor actually made of? Mud? Rock? Something else entirely? What were the physical conditions at the very bottom? The temperature? The chemistry? The pressure? Was it even possible to methodically, scientifically, examine a realm that existed entirely in the dark, under miles of water? The abyss was unknown, but was it unknowable? Studying the deep in this era was a brutally difficult, frustrating business. Anyone hoping to pry knowledge from the ocean's underworld had to spend months, even years, at sea, on cramped, rolling ships, eating hardtack and suffering from constant seasickness. The equipment they had was primitive by our standards. Depths were measured with a heavy weight on a very long rope. The only way to get a physical chunk of the seafloor, and maybe, just maybe, catch some deep-sea animals, was with a dredge, essentially a heavy metal frame with a net bag attached. These contraptions broke often. The long hemp ropes snapped under the strain. Working at depths of more than about 1,800 feet was incredibly slow, back-breaking labor for the ship's crew. The 1823 edition of the Encyclopedia Britannica, one of the most respected sources of knowledge at the time, simply gave up, stating flatly, "Through want of instruments, the sea beyond a certain depth has been found unfathomable." Well, by the mid-19th century, there was a new, pressing, and very practical reason to learn more about the seafloor: the ambitious project of laying transatlantic telegraph cables. Again, the deep became commercially and strategically important. The ability to send fast communications across the ocean meant a massive economic and military advantage. This strategic imperative led to a decade-long technological race on the bottom of the Atlantic, as Great Britain and the United States tried to run a 2,000-mile-long cable from Ireland to Newfoundland. But where to put it? How deep was it? What was the terrain like? How could they secure it? And a question Olaus Magnus would have appreciated: what strange creatures might chew through it in the dark depths? Expertise in the deep ocean was needed, urgently. And it was around this time, strangely enough, that sea monsters made a major dramatic comeback. Suddenly it seemed like everyone, from seasoned sailors to casual beachgoers, was seeing one. And this time, even some prominent, respected scientists believed in them. Their support for the existence of modern sea monsters was largely due to the recent, astonishing unearthing of fossils from giant, ancient marine reptiles like the ichthyosaur and the plesiosaur. If these huge finned dragons once prowled the deep, who was to say they weren't still down there hiding in the unexplored abyss? The brilliant and combative British biologist Thomas Henry Huxley, a man known as Darwin's bulldog, argued that there was no logical reason why 50-foot snake-bodied reptiles shouldn't still be swimming in our seas. Right, so that brings us to Richard Owen, the celebrated paleontologist who had actually coined the word dinosaur. He was a loud and powerful dissenting voice in this debate. He was absolutely convinced that the hysterical public was just misidentifying known animals, like basking sharks, giant squid, and schools of dolphins. But the romantic idea that the abyss harbored prehistoric living fossils wasn't going to be dismissed so easily. The deep was such a strange, alien, lost world. It seemed so removed from the extinctions and the evolutionary pressures that had shaped life on land that it felt almost logical for these kinds of ancient creatures to be lurking down there, unchanged by time. We just hadn't found them yet. And then, in a fjord in Norway, someone did. In 1864, a Norwegian naturalist named Michael Sars and his son, Georg Ossian Sars, were dredging at a depth of 1,800 feet. They pulled up a strange, archaic-looking animal known as a stalked crinoid. It was hardly a monster. In fact, it looked more like a delicate, beautiful flower on a long stem. These crinoids, or sea lilies, were abundant in the fossil record from hundreds of millions of years ago and were widely presumed to have died out with the dinosaurs. But here was a living, thriving specimen that seemed to have defied the relentless march of time. The appearance of this living sea lily was startling. A true living fossil. And what's more, it shouldn't have been found at that depth. According to the leading scientific theory of the day, no creatures at all should have been found at that depth, because in another great twist of irony in the history of oceanography, Just as the abyss was starting to get serious attention, one of the world's most respected and influential naturalists, Professor Edward Forbes of the University of Edinburgh, had declared that at a depth of 300 fathoms, 1,800 feet, and below, the deep ocean was Xnoesis. Completely and utterly lifeless, there was nothing down there at all. Let's see, Forbes's theory, the azoic hypothesis, wasn't entirely new. The Greek philosopher Socrates, centuries earlier, had delivered a similar pessimistic verdict on the deep. Everything is corroded by the brine. There is nothing in the sea that is perfect or worthy of note, only caverns and sand and measureless mud. Others in Forbes's time believed that the immense pressure compacted the sea floor into a solid block of cement, and that the water just above it was so stagnant and ultra-dense from the pressure that nothing could sink all the way to the bottom. Everything that fell into the ocean, the wrecks of ships, the bodies of sailors, the remains of monsters, would just hang there, suspended forever in the abyss, like they were lost in a strange, watery outer space. Of course, there was absolutely no evidence for any of this, but coming from a scientist of Edward Forbes's stature, the Xnoesis theory took on the weight of established fact. He was smart, charismatic, energetic, well-connected. His reputation as a naturalist was unmatched. He was a huge enthusiast for ocean exploration, but his own personal experience was limited, mostly to the shallower coastal waters. In 1841, he joined a survey expedition in the Aegean Sea, and the results of his deep dredging were frustrating. Mostly, his dredge came up empty, or with just a bit of mud. Later, it became clear that his dredge was probably too small and light to work effectively at depth. Also, the particular area of the Mediterranean he was working in is now known to be basically an aquatic desert, with very little life in its deeper waters. But at the time, Forbes made a wild, speculative leap. If he hadn't found life at depth, maybe it was because there was no life there to find. He put forward the elegant and simple theory that would secure his place in ocean history, though not quite in the way he'd hoped. As we descend deeper and deeper in this region, Forbes wrote, its inhabitants become more and more modified, and fewer in number, indicating our approach towards an abyss where life is either extinguished or exhibits but a few sparks to mark its lingering presence. Well, this was certainly news to Michael and Georg Sars in Norway, who by that time had found at least 19 different species living in the supposedly lifeless abyss of their local fjord. And it would have been news to the polar explorer Sir John Ross, who way back in 1818 had brought up worms and a spectacular multi-armed starfish from a depth of 6,000 feet in Baffin Bay. And to his nephew, Sir James Clark Ross, who in 1839 sailed to Antarctica, dredged up corals, jellyfish, and worms from 400 fathoms, and concluded that the Antarctic seabed was teeming with animal life. For a variety of reasons, all of these important discoveries were just ignored or explained away. The scientific community of the time largely embraced Forbes's Xnoesis theory because, on the surface, it made perfect, logical sense. The deep was a hostile, impenetrable environment. As far as anyone knew, there was no sunlight for photosynthesis, no oxygen, no food. Just colossal, life-crushing pressure and absolute cold. To write off the abyss as a dead zone was a neat, tidy solution to a mind-bending mystery. How could life possibly thrive without any of those essential ingredients? I mean, Forbes himself passed away tragically young in 1854, but his powerful Xnoesis theory didn't. It just lingered like a ghost in the machine of science for years, even as more and more animals kept showing up from inconveniently great depths. In 1860, a ship called the HMS Bulldog was sounding the depths of the North Atlantic for a new telegraph cable route. When they pulled up their sounding line from 7,560 feet, they were astonished to find 13 living brittle stars clinging to it. They were wriggling their long, spiny arms on the deck of the ship. The ship's naturalist, an ambitious and somewhat prickly man named George Wallach, was ecstatic. He had set out on the voyage specifically to make a name for himself by proving Forbes wrong, and in his mind, with these wriggling starfish, he had definitively succeeded. But his brittle stars were met with widespread skepticism. Critics argued they must have gotten tangled in the line on the way up, in shallower water. The doubts remained. The AZOIC theory, though wounded, wasn't quite dead yet. A brilliant Scottish naturalist named Charles Wyville Thomson was following this whole debate very closely. He was convinced that much more, and much better, dredging needed to be done, at even greater depths, with better, more reliable equipment. In 1868, he and a colleague, William Carpenter, who was the vice president of the prestigious Royal Society, asked the British Admiralty to support a 6-week exploratory expedition. They were given an old rickety paddle steamer called the HMS Lightning, mainly because it was falling apart and not good for much else. But it had a small auxiliary steam engine that could be used to power a winch to lower and raise the heavy dredge. Foul weather plagued them throughout the voyage, and the old ship was tossed about mercilessly. But near the very end of the expedition, the weather finally settled down, and they were able to dredge successfully below 500 fathoms. And those few precious dips into the deep brought up animals that were worth all the trouble and seasickness. A fiery orange sea star with strange, curly arms. A primitive, ancient-looking mollusk. A stunning, ruby-red squat lobster with iridescent, coppery eyes. And several beautiful, intricate glass sponges. Thomson and Carpenter also found a hidden universe of microscopic life, tiny shelled organisms called foraminifera in the gray seafloor ooze. The results from the Lightning expedition were encouraging enough to earn them a much sturdier ship, more months of dredging time, and the chance to go even deeper. The following spring, in 1869, they returned to sea on the HMS Porcupine, and so on this new, more capable vessel, their luck finally changed. The weather calmed, the modern steam-powered equipment worked flawlessly, and they successfully dredged as deep as 14,610 feet, nearly 3 miles down. Week after week, the dredge rose from the abyss loaded with splendid, otherworldly goblins. Thomson, working on the deck, sifted through the cold, wet muck, carefully picking out astonishing new species, including a skeleton shrimp, a glistening, ghostly, mantis-like creature, a pristine, deep pink starfish, and a giant sea spider with spindly legs as long as a human's. The deep released a kaleidoscope of strange and wonderful beings, many of which, he noted, shone with their own living light, with bioluminescence. In some places, Thomson wrote in his log, nearly everything brought up seemed to emit light. Even the mud itself sparkled. The worms glittered like living gems. Gorgonian corals radiated a soft, constant white glow. Far from being a black, lifeless hole, the depths, it turned out, were ablaze with their own cold fireworks. Using new, specially designed, pressure-tolerant thermometers, Thomson and Carpenter also took the first reliable temperature readings near the seafloor and found, to their surprise, that the temperatures fluctuated. The abyss was not frozen solid, and it wasn't inert. There were great, slow-moving currents of water moving down there, like deep-sea rivers, independent of the winds and currents on the surface. By now, they had completely and utterly disproven the AZOIC theory, though amazingly, some of its most ardent supporters still refused to give up. After the stunning success of the Porcupine voyages, Thomson and Carpenter were given government approval for the most massive, ambitious oceanographic exploration ever conceived, a 3.5-year global circumnavigation with every scientific resource imaginable, all paid for by Her Majesty Queen Victoria's government. The goal was simple and audacious: to thoroughly survey the deep oceans of the entire world, to search for new species, for living fossils, for reclusive sea monsters, and for anything else that might be concealed in the vast, dark abyss. And, once and for all, to hammer the last nail into the coffin of the Xnoesis theory. The ship chosen for this grand voyage was a 226-foot naval corvette. Its guns were removed to make room for laboratories and storage. Its name was the HMS Challenger. You know, over the course of 3.5 years, the Challenger and its crew of scientists and sailors traveled 68,890 nautical miles, a journey that took them around the entire globe. Their route took them to the very edge of Antarctica's Great Ice Barrier, into the archipelagos of Indonesia and the Philippines, and along both the Atlantic and Pacific coasts of Africa and South America. They took hundreds of soundings and dredgings. On one memorable occasion, about 300 miles off the coast of Japan, they dropped their sounding line, and it just kept going and going. They measured a depth of 27,450 feet, more than 5 miles. The measurement was such an extreme outlier that they thought it must be a mistake, and they repeated it. It was correct. What gaped silently below their ship gave a new, terrifying meaning to the word abyss. We now know it as the Mariana Trench. The ship finally returned to England on May 24, 1876. Huge crowds lined the docks at Portsmouth to cheer their heroic return. After the French author Jules Verne's blockbuster novel 20,000 Leagues Under the Sea was released in 1870, the deep sea and the abyss were all the rage. The sea is merely the medium which supports the most fantastic, prodigious forms of existence, Verne's obsessed, brilliant Captain Nemo declared. And now here was the HMS Challenger, pulling triumphantly into port with the receipts, a staggering collection of nearly 5,000 never-before-seen species, jars of sediment samples from every ocean basin, and enough raw data on temperature, depth, and currents to keep the world's scientists busy for the next 20 years. The final 50-volume Challenger report made everything that had come before it instantly obsolete. So much of the conventional wisdom, so many of the long-held preconceived notions about the deep had turned out to be completely wrong. Now it could be said, with overwhelming, irrefutable evidence, the deep sure as hell wasn't Xnoesis. And it wasn't a static, unchanging hideout for prehistoric creatures that had somehow managed to avoid evolution for 100 million years. The animals they found were ancient in lineage, but they were modern, evolving creatures. As for the distribution of life, it was, to their surprise, everywhere. The Challenger team found similar types of animals roaming the abyssal depths no matter where in the world they looked, even when great underwater mountain ranges should have kept them separated. And far from dwindling to a few sparks as Forbes had predicted, in some cases, abyssal life forms grew to gigantic proportions, a phenomenon now known as abyssal gigantism. Wow! Even today, it's hard to overstate the Challenger's incredible success. What a legacy! What an odyssey! It fundamentally transformed our understanding of our own planet and left a trove of tantalizing clues for future generations of investigators. Instead of a map filled with fearful monsters, Wyville Thomson and his team had given the world a compass and 50 thick volumes of reasons to keep seeking knowledge in the dark, silent depths. Thomson himself described the deep as an enchanted region, but that very enchantment perplexed him. The incredible elegance of a glass sponge's silica skeleton, the perfect mathematical symmetry of deep-sea corals. It all raised the same philosophical question for him. Why? Why would nature go to the trouble of creating something so exquisitely beautiful, and then put it in a place of total darkness and crushing pressure where nobody would ever see it? Thomson found himself amazed at the recklessness of beauty, which produces such structures to live and die forever invisible to human eyes in the mud and darkness of the abysses of the sea. Of course, in his very human-centric view, he was forgetting that the deep's beauty was fully accessible to the countless other creatures that lived there, who experienced their world through senses we can barely imagine. But Thompson's lament was more specific, that the abyss was forever invisible to human eyes. He was half right. At the time, people couldn't witness the glories of the deep firsthand. But our blindness, it was only temporary. A man named William Beebe wanted to go first. He was a character, a man who loved birds, tropical jungles, strong cocktails, grand expeditions, costume parties, natural history museums, marine life, writing books, popular science, and women, and not necessarily in that order. Beebe was an unlikely celebrity in the glamorous, roaring 20s. He was, at heart, a nerd, but an incredibly energetic and charismatic one with a natural flair for dramatic storytelling. He wanted to study every animal on Earth. While working in the Galapagos Islands, he experimented with helmet diving, clomping along the shallow seafloor in a heavy copper headgear, tethered to a boat on the surface by a long air hose. Beebe was absolutely stunned by the fantasia of colors and creatures he saw on a coral reef. His long-time interest in the sea flared into a full-blown obsession. Back in his office in Manhattan, he charmed some wealthy financiers into giving him a research ship. Not long after, Britain's Prince George offered him the use of a private island in Bermuda. It was the ideal base of operations for Beebe's next incredibly ambitious project. He wanted to survey all of the life forms within a single 8-mile square, 2-mile deep cube of the ocean. Right, so that brings us to the severe limits of the technology at the time. Beebe quickly became deeply frustrated by the limitations of dredging and trawling. Most of the delicate, gelatinous creatures he netted from the deep came up mangled, torn, and often dead, beyond recognition. This was a half-assed, blind method, Beebe concluded. To get a true, accurate picture of deep-sea life, he'd have to go down there and see it for himself, in its natural environment. He envisioned being lowered a mile into the ocean in a specially designed cylindrical steel capsule. Knowing that a bit of media attention would help him raise the cash to build it, Beebe announced his bold plans to the press. He would become the first man ever to study the deep in person. On Manhattan's Upper East Side, a 26-year-old engineering student named Otis Barton read the New York Times headline, "Beebe to explore ocean bed in tank," with a jolt of alarm. Barton, himself an avid sailor and diver, had his own secret plans to become the first man into the deep. He, too, had designed a submersible. Maybe, he thought, Beebe would agree to a partnership. Barton had a major advantage in this situation. He was very rich. Plus, he knew from his engineering studies that Beebe's proposed cylindrical design invited certain disaster. It was completely the wrong shape. Only a perfect sphere could reliably withstand the deep's immense, uniform pressures, because the crushing force would be distributed equally across all points of its surface. A cylinder with its flat ends would get crushed like a tin can. He reached out to Beebe with a proposal. Let's see. When Beebe saw the detailed blueprints for Barton's vessel, he was immediately impressed. Barton's design was brutal and elegant in its simplicity. A hollow steel ball, cast in a single piece, with walls 1.5 inches thick. It was just shy of 5 feet in diameter, with 3 small circular viewports made of 3-inch thick fused quartz, the strongest transparent material available. If comfort wasn't a priority, 2 people could just barely fit inside. Entry and exit were through a heavy, 14-inch top hatch that would be sealed from the outside with 10 massive bolts. The sphere could be winched into the depths on a thick steel cable. It could work, Beebe thought. They struck a deal. Barton would foot the entire bill for construction and supervise the building of what Beebe had already brilliantly christened the bathysphere. Beebe, with his fame and connections, would provide a winch, a ship, a crew, and maximum publicity for their joint venture. They would both go first. On June 6, 1930, they made their inaugural dive, bolted into the cramped, cold, dark bathysphere, swung out over the deep blue Atlantic off the coast of Bermuda, their bodies folded up like origami. The two men could only hope that they hadn't overlooked some small, crucial detail in their calculations. So many things could go wrong. The cable could snap, the sphere could leak, it could implode. Any leak, even a tiny one, could be instantly fatal. Under the deep's incredible pressure, water would shoot through even a pin-sized hole with the force of a machine gun bullet. And if, God forbid, the main cable snapped, the heavy bathysphere would cannonball to the sea floor, and Beebe and Barton would find themselves trapped 2 miles down in a ready-made spherical steel coffin. The bathysphere was lowered slowly into the ocean. At 200 feet, the red and yellow wavelengths of sunlight had been filtered out by the water, leaving only a world of green, blue, and violet. When a crimson-colored deep-sea shrimp darted by the viewport, it appeared completely jet black. At 300 feet, they stopped the descent abruptly when Barton noticed a small trickle of water coming in through the main hatch. Instead of panicking and demanding to be brought up, Beebe, thinking on his feet, coolly asked for the bathysphere to be lowered more quickly. He guessed correctly that the increasing external pressure would push the heavy hatch down more tightly and seal the leak. It worked. The descent continued. At 700 feet, Beebe called for a pause just to absorb his surreal surroundings. "Only dead men have sunk below this," he noted in his logbook. What really struck him, what he would write about for the rest of his life, was the uncanny, otherworldly quality of the light. Only the last pinch of the visible spectrum remained, its deep indigo embers seeming to glow with a brilliant purity. On the very brink of utter darkness, the final traces of sunlight appeared eerily, intensely radiant. "We were the first living men to look out at this strange illumination, and it was stranger than any imagination could have conceived," Beebe would later write. "It was of an indefinable translucent blue, quite unlike anything I have ever seen in the upper world." The blue, he felt, was so piercingly vivid, so emotionally resonant, that language itself failed to describe it. It was more like an emotion than a color. Okay, so over the next 4 years, Beebe and Barton made 33 more dives in the bathysphere, eventually reaching a record-breaking depth of 3,028 feet, more than half a mile down into the midnight zone. The realm below 600 feet, Beebe learned, was a pulsing, flashing nightclub of life. He watched, completely mesmerized, as sawtooth eels with terrifying pincer jaws twisted their long, snaky bodies to get at the bait they had hung outside the viewport, and troops of winged pelagic snails fluttered by like a swarm of deep-sea pixies. 6-inch-long dragonfish, with dagger-like teeth and luminous, glowing barbells swinging from their chins, emerged as tiny, terrifying frights in the inky black water. A whole gang of silvery hatchetfish, palm-sized predators with huge, bulbous, upward-looking eyes and gaping vertical mouths, glittered like living tinsel. Little green, glowing lanternfish twinkled past the bathysphere in a silent, sparkling chorus line. The deeper they went, the more dashes and streaks and brilliant arcs of bioluminescence flared in the darkness like strange intergalactic signals. Beebe and Barton were the very first human beings to witness the deep ocean's own secret pyrotechnics. Even more haunting were the stealthy visitors that didn't advertise their presence with lights, advancing under the cover of absolute darkness. Beebe often sensed the ghostly, indistinct forms of larger beasts moving just beyond the narrow scope of their searchlight. One time, at a depth of 2,450 feet, he caught a fleeting glimpse of a true behemoth. 20 feet is the least possible estimate I can give to its full length, he wrote breathlessly. He had no idea what it was and never saw it again. The dives went smoothly for the most part, but two near tragedies during unmanned test dives showed that luck played a bigger role in their success than anyone cared to admit. Twice, the caulking around a viewport blew out under pressure and the bathysphere flooded completely. The partnership itself turned out to be the most vexing part of the whole project. The two men, the flamboyant scientist and the reserved engineer, were in a kind of shotgun marriage of convenience, and neither of them particularly liked it. After their last record-breaking dive, they parted ways and, according to most accounts, never spoke to each other again. The abyss carried on, unobserved again, in its timeless, silent fashion. But then, in 1948, a Swiss physicist and adventurer named Auguste Piccard unveiled a new machine he'd been working on, a new kind of submersible. It was a true successor to the bathysphere and a radical upgrade. To Piccard, the very idea of being yoked to the surface by a long, vulnerable cable was absurd. His vessel was designed to be autonomous, untethered, free-roaming, and he intended to take it far, far deeper than Beebe and Barton had ever dreamed of going. It was a hulking, strange-looking sub that, more than anything else, resembled a kind of underwater zeppelin. Piccard called his invention a bathyscaphe, which means deep ship in Greek. And so, on January 23, 1960, the bathyscaphe, which had been rebuilt, renamed the Trieste, and was now the property of the U.S. Navy, was scheduled to descend into the deepest part of the Mariana Trench and touch down in a 30-mile-long, 5-mile-wide slot at the bottom, known as Challenger Deep, the ocean's most profound and inaccessible destination. This was a completely different ballgame. This was no gentle dunk in the warm waters of Bermuda. This was a trip to the literal bottom of a yawning tectonic crevasse in the bowels of the Pacific Ocean. You know, the Trieste worked on a beautifully simple principle, like an underwater hot air balloon, if it were headed down instead of up. The steel passenger sphere, which was even smaller and more cramped than the bathysphere, hung like a gondola beneath a 60-foot-long, blimp-shaped float. Piccard's brilliant idea was to fill the float with 28,000 gallons of gasoline, a fluid that is fairly incompressible and, crucially, is lighter than water, and attach 10 tons of iron ballast weights with electromagnets. To descend, the pilot would vent some of the air in the float's ballast tanks, allowing heavier seawater to flow in for negative buoyancy. To ascend, he'd simply flip a switch, cutting the power to the electromagnets and dropping the heavy ballast weights. Challenger Deep is as special and as problematic as it gets, so the U.S. Navy had only one seat available on the historic dive. It went to a young, 28-year-old submarine lieutenant named Don Walsh. He'd volunteered for Trieste duty before he even knew the full scope of what it entailed. "I just thought it would be fun," he later told a reporter. "Something different, you know." Fun, sure. If your idea of fun is test piloting a highly experimental vehicle into a completely unexplored realm so savagely unaccommodating to human life that a single, small mistake might result in your bones being mashed into a liquid pulp by the weight of the entire ocean. No one involved was out to be a daredevil. It was all about calculated risk. But there was simply no way to fail-proof a dive into the Mariana Trench. There were just too many unknowns. Walsh and Jacques Piccard, Auguste's son who was co-piloting the mission, didn't even know for sure what kind of terrain they'd be landing on. One Navy scientist was seriously concerned that the trench floor might be a kind of primordial, gooey soup that would behave like quicksand. Could we sink into this material and disappear before even being aware that we had contacted the bottom? Picard worried in his journal. Well, at a depth of 31,000 feet, that quiet was ended by a sudden moment of sphincter-clenching terror, when a dull, deep bang, like a muffled explosion, shook the entire sphere. "It got our attention," Walsh noted with his typical, characteristic understatement, but the Trieste continued its slow descent, and nothing calamitous seemed to ensue, so they shrugged nervously at each other in the dark and kept going. Later, after the dive, they figured out that an outer pane of the acrylic window in the entry tunnel high above the sphere had cracked under the immense pressure. This wasn't ideal, but it also wasn't fatal. When the seafloor finally came into view in the beam of their searchlight, their external lights reflected off what Picard later described as a uniform, flat waste of snuff-colored ooze. "Good, we've made it," Walsh said, his eye pressed tightly to the thick viewport. The trench floor was smooth and flat, blanketed with a sediment so fine and light that when the Trieste finally touched down, it stirred up a milky, opaque fog. In their brief 20 minutes of bottom time, Walsh and Picard did spy something that looked like a long, flat fish swimming away. Our first tantalizing clue that Hades wasn't an empty tomb after all. And then, after their triumphant return, silence again. For more than half a century, no one went back. On March 26, 2012, the film director and passionate ocean explorer James Cameron became only the third person in history to touch down in Challenger Deep, and the very first to do it solo in a futuristic, custom-built one-man sub, 52 long years after Walsh and Picard had descended in the Trieste. When you consider that during that same half-century, more than 200 people flew to the International Space Station and thousands of climbers stood atop Mount Everest, it's truly boggling that it took humanity so long to make a second trip to the bottom of our own world. You know, I was just thinking, Cameron's daring dive was a powerful reminder to the world that the great depths were still down there, and they were still almost completely unexplored. "In the space of one day, I've gone to another planet and come back," he said upon surfacing, his face etched with awe and exhaustion. But Cameron's revolutionary submersible, the Deep-Sea Challenger, a sleek neon green, vertically oriented vehicle, never dived again. It was a prototype, a vehicle built for one specific, historic mission. During its 2 hours and 38 minutes on the trench floor, 11 of the sub's 12 thrusters had failed, among other serious mechanical problems. 7 more years had passed since then, an eternity in technological time. Everything had advanced: battery technology, materials, science, electronics, software. And then, a driven Texas businessman and private equity investor and explorer named Victor Vescovo contracted with a private company, Triton Submarines, to build a 2-person sub that could dive to and, crucially, return from the deepest places in the ocean, including Challenger Deep. Not just once, but repeatedly. This wasn't just a request, it was a challenge that pushed the very limits of engineering. A safe, reliable, and reusable Hadal passenger sub. Was that an oxymoron? You're dealing with the most stubborn laws of physics, with the most basic questions of how to keep a person alive and comfortable inside a tiny bubble that's being stomped on by 16,000 pounds of pressure per square inch. The sub would need to be strong enough to withstand implosion, but also nimble and agile enough to handle rugged, unknown underwater terrain. Every single wire, every bolt, every circuit board, and every battery on it, every last capacitor, O-ring, and gasket would need to be fail-safe under gargantuan pressures, in near-freezing temperatures, and in highly corrosive salt water. And they would need to stay that way, dive after dive. For a whole raft of technical, financial, and even psychological reasons, such a vehicle had never existed before. But Triton Submarines accepted Vescovo's commission, and more importantly, they successfully completed the monumental task. In late 2018, the company debuted a full ocean-depth submersible that resembled nothing that had come before it. Sleek, white, and futuristic, it was named the limiting factor. On December 19, 2018, Vescovo piloted his new sub on its first Hadal dive, plunging 27,480 feet to the bottom of the Puerto Rico Trench in the Atlantic. That alone was a champagne-popping historic feat, but Vescovo was just getting started. His goal was to become the first person to dive to the deepest points in all 5 of the world's ocean basins. And so, the expedition was named the 5 Deeps. His reason for pursuing this incredibly difficult and dangerous goal was simple and pure, because nobody had ever done it before. And so, history was being made again, right in front of us, by a new generation of explorers. After Puerto Rico, the 5 Deeps team continued its unprecedented run of Hadal dives, conquering the South Sandwich Trench in the Southern Ocean. Then, in May 2019, Victor Vescovo became the 4th person ever to touch down in Challenger Deep. He and Patrick Leahy, Triton's president, went on to pilot 4 more successful dives in the Mariana Trench, for a total of 5 separate plunges below 35,000 feet. And now, the expedition was on to its next great Pacific quest, the first ever manned exploration of Challenger Deep's twisted, even more remote sister, the Horizon Deep in the Tonga Trench. Every single dive into the Hadal zone was a dive to somewhere we had never been before. Every deep dive was a first. Every trench was more complex, more geologically active, and more biologically unique than we knew, and no 2 trenches were the same. But even this unprecedented, historic series of dives was, in a way, just a prelude. The real revolution, the quiet, systemic, and almost completely unnoticed revolution, was unfolding somewhere else. In the hands of a country that had looked at this history of heroic, one-off exploration and decided to take a different path. A country that had turned exploration from a singular celebrated feat into a repeatable, industrial process. And the consequences of that strategic shift would eventually be felt by the entire world.